Hello, and as you can see, I'm okay, all right? And I apologize for not being able to do your exams yet, but I'll get to them today. And for now, I just wanted to give you a little perspective on what we've done so far and where we're going for this week. What are the lessons for this week? Okay, so last week, what we really did is try to analyze the different circuits that you can encounter in DC currents. Okay, normally what happens is a design engineer will design up a circuit. Okay, then he has to prove it out. Okay, how does it work? So last week we found different ways of which we can analyze the circuits. Okay, basically three or four different ways we can do that. Uh, and then the designer it's, himself has to, or herself has to change a few elements around to make it work better. Unfortunately, the tests don't always prove out to be 100% accurate. Okay, so basically you have, after you've created a prototype circuit, you test it out differently using different equipment. You mainly check out all the different voltages and see if it jibes with what your theoretical values are when you used your analysis tools. So, and when they don't check out, then you have to test them and make arrangements. But what the reason it doesn't work is because most of the components, resistors, capacitors, and whatnot, don't behave the 100% way. Okay, they don't. Resistors have other components, have other elements to it that make them work a little differently depending on the current values that are used, and actually, if it's used in AC circuits, um, they can look like inductors or capacitors. Okay, and so the engineer has to make checks. All right, so once the uh, circuit is uh, created and tested out and performs just like it should, you basically now are in a mode where you can build up an actual electronic unit, usually some kind of a black box, we call it. Okay, now that black box will go into an aircraft, or it'll go into a submarine or some kind of a naval ship and so forth, and it has to do certain functions on either the ship or the aircraft. So once you build the unit, you send it through what we call ATP, automatic test procedure. Okay, and that test procedure then means you take that box that you've created or manufactured periodically, you hook it up to this piece of equipment, ATE, automatic test equipment. Okay, hook it up, and that equipment itself um, puts in signals into the box that the box itself has to react to and give out certain information. So if it gives out the wrong information, then you go back to retesting. Okay, what's happening? What, can I correct it into this box? So it has to pass ATP before it gets sent out or put onto a ship or an aircraft. So the procedure then is to create a ATE, automatic test equipment. Now, how do you do that? Okay, the automatic test equipment itself has to simulate what actually an aircraft does or a submarine does and so forth. Okay, so you create certain circuits into that ATE equipment, okay, and it has to simulate exactly what the ship or the aircraft does. Now, how do you do that? Well, the circuits that you build then have to be, they're not as critical, okay, as the box itself, what's in the box itself. So you take shortcuts, okay, and this week we will go into some of the shortcuts that can be taken when you have a circuit that has multiple energy or voltage units or current units, uh, stuff that actually process power to or sends power to your equipment, to your circuits. So the first thing that we'll do, though, first today, Monday, we go through another analysis tool, okay, which is pretty neat. It's superposition, which basically assumes, okay, you have a circuit with multiple power units, okay, and this is a easy method to check to see, okay, what happens if only this power unit works, okay, and then you check what happens if this other power unit works, okay, what is the contribution to the circuit. So we find out one, and we found out the other, and then we combine the two to figure out, okay, what is the net effect of both power unit A and power unit B to be operating. So the superposition method is very simple, and it basically obeys one of my favorite theories of um, the whole is equal to the sum of its parts. In this case, the sum of its parts, it has two parts. It has um, power A and power B. Okay, you find out what power A does to the unit, find out what power B does to the unit, you combine them, and get the actual effect. So that's another analysis tool. Now, the other two elements that are important are, okay, if I create a circuit, all right, with a certain power and a resistor network and so forth, can I condense that into just giving me a unit that has one power unit and one resistor? Okay, and you can. Okay, that is the second method of that we'll go to tomorrow or Tuesday and Wednesday. The other way is, instead of a voltage power unit, we can have a unit that delivers current, all right? Uh, a current source. So we call it a voltage source versus a current source. Okay, so those are two different analyses that we can perform, or actually substitutions that we can perform that simplify a circuit. And that's what we're going to be studying today, tomorrow, and the next day. Okay, and then we'll get to the other information later on this week. So gives you a perspective of what we're really trying to do, and I'll get to your exams and give you all what how well you did, and maybe give you some advice as to where to go from now. Okay, so take care. I'll see you next time. Bye bye.